Okay, I hope by now you're kind of getting the hang of this kind of arithmetic we do with the factorials and with the powers and breaking them up. So here's our series n factorial times x minus 4 to the n. So this doesn't look quite as complicated. So we're going to take this limit, and this limit will equal L. And remember, by the ratio test, if L is less than 1, or we'll set it less than 1, then we'll be in good shape if we can do that. So this is going to be my n plus 1 factorial, x minus 4 to the n plus 1, all over this. And I just actually wrote it as a fraction because this was a small. These are just single. They weren't rational expressions, so I could write this in the bottom. So n factorial over n minus 4. And then I could break this up, so I could write this as, again, this is a little trick, n plus 1 times n factorial. Because that's n plus 1, and that's basically a way of breaking it up. So n plus 1 times n factorial is the same thing as n plus 1 factorial. All over n factorial. So my n factorial is a cancel. And the same thing, I'll write this as x minus 4 to the n times x minus 4 over x minus 4 to the n. So those can cancel. So my n factorials cancel. My x minus 4 to the n's cancel. This is what I have. Now if I take the limit, I don't get any help. That's just going to be infinity. That's greater than 1, so it diverges. So where does it converge? Every series converges about its center. The center here is 4. Remember, it's x minus a is the center. So it converges only 4. X equals 4. The radius of convergence is 0. That's just right at the center. Okay? So I hope that helps. Okay, number 18. Okay, here's number 18. Let me get this up. So hopefully you can pause it and zoom in if you have to. Hopefully you can find all that stuff. So again, we're going to use the ratio test here. And again, this limit will equal L. And we can take absolute convergence. That's going to assure convergence if we can show that by using the ratio test. So again, this is going to be my a sub n plus 1. So every time I see an n, I put an n plus 1. So that's the square root of n plus 1, x to the n plus 1, 3 to the n plus 1. And then the reciprocal, which is 3 to the n, over the square root of n, x to the n. So we want to get this limit, and we want to get all the n stuff in the front eventually, but cancel it whenever we can. So I did a nice extra step. I wrote this as the square root of n plus 1, and this is x to the n times x, and then 3 to the n times 3. That's 3 to the first, okay? And that's going to allow me to get some simplification going. So the 3 to the n's cancel. They become 1 of the x to the n's cancel. So what's left is x to the n plus 1 all over the square root of n. Sorry, the square root of n. The square root of n plus 1 all over the square root of n. And then I've got just the absolute value of x over 3. And I put this all under the same radical. And if I take the limit of this, it's just the limit of that. And again, this is going to be the same idea. The limit of this is going to be the square root of the limit. Doesn't matter. This is 1. If I take the limit of all this, this is going to be 1. Again, we've seen this before. The ratio of the ratio of these. In other words, you can make this to the 1/2 power, then you could just put it in front. It works as a power rule for our limits. That is going to be the same thing. So that's just going to be 1. So there we go. And then again, we multiply both sides by 3. We get the absolute value of x is less than 3, so my radius of convergence is 3. So again, just realize that, and another way you could do it is you could just say, as n approaches infinity, this becomes so small, I just have the square root of n over the square root of n, which is 1. There's all kinds of ways of doing it. Okay, so whatever works for you, but either way, that limit again definitely is 1. All right. Okay, let's take a look at number 19. And again, we got alternating series. So this is going to be a nice situation when we can use the absolute value, because that's going to get rid of the negatives, and that's going to make things cancel a lot easier. So basically, this was our series: negative 2 to the n, n plus 1, x minus n to the n power. So again, this is going to be my top. So I can write this as a fraction because there aren't any rational. It's not a rational expression. So it'd be easy just to write in this form. So here's negative 2 to the n plus 1, n plus 1 plus 1. So there's every time I see an n, I put an n plus 1, so n plus 1 plus 1, and then x minus n to the n plus 1 all over this original series, negative 2 to the n plus 1, and x minus 1 to the n. Okay, then I broke this up, and because we had the absolute value, I just can get rid of the negative sign. So this is going to be 2, that's 2 to the first, and then 2 to the n. And then this is n plus 2. All right, and this was my x minus 1 to the n over x minus 1, so I could cancel. Here's the bottom, basically in the same form I just broke up, got rid of some of the absolute values, and you can see how those 2 to the n's cancel, and how these x minus 1s to the n's cancel. So I end up with 2 n plus 2 all over n plus 1 times the absolute value of x minus 1. And the limit of this, if we look at the limit of this part's going to be 1, or if I look at the ratio, 2n over n is just 2. And times this. So this is going to be my inequality, and this is going to be my L. So whenever L is less than 1, this equals L, this limit. So when that's less than 1, it converges. So I make it less than 1 to see when it converges, and divide both sides by 2 to get it in the form x minus a, and there we go. So I hope that helps. And number 20. All right, and then we have this series again, and we're going to use the ratio test, and we're going to write this limit, and that's going to be L. Pardon me. So every time I see an n, I put an n plus 1. So n plus 1 here. Over this. Here, pardon me, I got a cough. Sorry about this. Pardon me. Okay, sorry about that. Okay, so I've got 4x minus 5. Okay, so 2n plus 1, so that's going to be 2 times n plus 1 plus 1. Every time I see an n, I put an n plus 1. And this is going to be n plus 1 to the 3 halves. And then I just write the reciprocal of this, n to the 3 halves, all over 4x minus 5, and that's going to be to the 2n plus 1. Now, I don't know how I'm going to simplify these. I can multiply this out. This is going to be 2n plus 2 plus 1 is 2n plus 3. And this is going to be n plus 1 to the 3 halves, n to the 3 halves. I think I might be stuck with this. We'll see. Okay, yep. And then I can simplify this somewhat because I can subtract this exponent from that, and I'm just going to have, well, let's kind of write this up over here. So we have this, we broke this up so you can see the canceling. So I got 4x minus 5 to the 2n plus 2 times 4x minus 5 squared. So you can see how these cancel. And then over here, I just wrote this as is. This stays the same, this stays the same. And you can see how this part will cancel with that part. So now I have just this n to the 3 halves all over n plus 1 to the 3 halves. Yeah, I didn't think I was going to be able to get rid of that. Okay? And then I've got the 4x minus 5. Now these cancel here, so I just have the 4x minus 5 squared. So this is what I have. So now I got to look at this limit here. Now again, as n approaches infinity, this 1 absorbs into the end, so I can just get rid of it. And basically I have n to the 3 halves over n to the 3 halves, and what's that going to be? 1. So this limit is 1. So you have to kind of be creative about this and use some of the different little tricks we've used to deal with limits as n approaches infinity. So that's just going to be 1. So we just have this. So this is my L. So this converges whenever this is less than 1. Now remember, it has to be in the form of x, so we got to get rid of that x, but it's going to, I can take the square root of both sides, and that's going to be fine. So the square root of 1 is 1, so this is equivalent. So this is equivalent to this. But again, we've got to get the 4 out, so I'll divide 4 out. If I divide this by 4, I get x, and if I divide this by 4, I get 5 over 4. So now I'm all set. So I want this. This is my L again. This is my limit. I want that to be less than 1. So this is the inequality that will give it to me. Then if I divide both sides by 4, R is equal to 1/4. okay, because it's going to be less than 1/4. So that's my radius of convergence. This is going to be the center. So it's important that you do all the arithmetic because it's going to be x minus a. A is going to be my center, and that's going to be important a little bit later. Okay, I hope those help. And again, if you have any questions, please ask them tomorrow in class.